Okay, in the previous section, we used truth tables and truth functions to analyze statements and to compare statements into various types: tautologous, contradictory, consistent, comparing statements, logically equivalent, contradictory statements, or consistent statements, and so on and so forth. So we've done a bunch with respect to statements, but now we're going to use truth tables to analyze arguments, and then eventually in the next and final section to make proofs and arguments ourselves. So first off, when it comes to truth tables and arguments, we continue with what we learned in the last section about using truth tables to analyze and compare statements. And in this section, we'll learn how to use truth tables to determine whether an argument is valid or invalid. And the key point, and this is a point I have stressed from the very beginning, any argument where a false conclusion can be derived from true premises is invalid. And so let us turn to an example to see how truth tables can be used to determine whether an argument is valid or not. So here's an example of an argument. J implies E, not J, therefore not E. Okay? Now, one of the things we'll see when we look at fallacies, that this form of argument is called denying the antecedent, and we'll see that it is an invalid argument form, meaning that you can have true premises and a false conclusion. But before we learn these rules, I want to show how we can use truth tables to prove the same point, that it's an invalid logical form. So, to use truth tables to analyze arguments, the premises and conclusion are put on one line. Premises are separated by a single forward slash, and the premises from the conclusion by a double slash. This gives us the following. So we have done this already in earlier sections, but now it's going to become a little more important as we do truth table analyses of arguments. So we put the argument into one line. We have J implies E, not J, and the conclusion is not E. Okay? So let's do the truth table analysis. We have J implies E. So what we're supposed to do, if in a truth table analysis of an argument, is assume that we can have true conclusions leading to a false, true premises leading to a false conclusion. So, what's going on here? Okay, never mind. Putting all the lines out here. Okay, so that'll be later on when we do the indirect method. I'm getting a little bit ahead of myself. So what we have here is a complete truth table analysis of this argument. Right? So we have two statements, J and E. So as we learned in the last section, two statements means there will be 4 lines. If there were 3 statements, there would be 8 lines. So we start with J, and we do true, true, false, false. And then E, true, false, true, false. And so over this second premise, we have J, true, true, false, false, continuing with the same truth values from earlier. And then E, true, false, true, false. So now with E, it was negated, so let's flip the truth values. So the conclusion here would be false, true, true. J also has the negation, so its truth values get flipped. F, F, true, true. Okay? And now the truth value of J implies E. We have true implies true is true, true implies false is false, false implies true is true, and false implies false is true. Now we can see that this argument is invalid because on the third line you have true premises and a false conclusion. It doesn't have to happen on every line, it just has to happen on one line where you have true premises and a false conclusion. And this form is, as we will see later on, denying the antecedent. It is invalid logical form, but people often fall for it because it is very similar to the modus ponens argument form, which we'll be looking at in a little bit. So that's an example of how you use a truth table to analyze an argument to see if it's invalid or not. If you didn't have a case where it was true and false, then it would be a valid argument form, right? If on the third line it was true, false, and false, then it wouldn't have been an invalid argument form. But it's not. We have 2 true premises and a false conclusion. Now, it's easier, which is why I was getting ahead of myself, to do an indirect truth table analysis in order to prove validity or invalidity. And the way to go about it with an indirect truth table analysis is you simply assume with the assumption that the argument is invalid, and thus that it is possible to make the premises true and the conclusion false. If this cannot be done, in other words, if you work it out so that you can't make all the statements such that the premises are true and the conclusion is false, then the argument is valid. If it can be done, in other words, if you can do it such that the premises can be true and the conclusion false, then it's invalid. This says valid, but it actually should be invalid. So let's look at some examples.
Okay. We're going to do an indirect truth table now. So what we have here is we have this proof, not A implies B or C, not B, and the conclusion is C implies A. So we put this all on one line, like we learned a few slides ago, and we're going to use the indirect truth table method. So what that implies is that we assume that the conclusion is false. Okay, so we have a false conclusion, and the premises must be true. So what we try to do now is we try to make it possible to have the conclusion false and the premises true. Well, in a C implies A, the only time that this whole statement is false is when you have a true implies a false. So now that gives us the truth values for some of the other letters in some of the other premises. So we now know that C is true and A is false. Okay, but now the A is negated, so that makes the A true in this one. So we have true implies B or C, and then we know in the disjunction, the truth operation of the disjunction, it is only false when they are both false. So it doesn't really matter what B is. This one's going to turn out to be true. And so now we end up with the B, so it doesn't really matter. We can make this one true, so let's make B false, and the negation makes it true. And so B is false here, so false or true is still true. Let's see here. This premise is true. This premise, this is true implies true, makes the whole thing true. So this premise is true, right? You see, B or C, false or true is true. And then this A became true, so true implies true, makes the whole thing true. And so that's one premise. The second premise here is true, and the conclusion is false. So we thus have an invalid argument. So as you can see, it's fairly easy. It's a lot quicker than going the whole truth table method because we have three propositions here. We would have had to use 8 truth table lines in order to go through all the possible truth values. And we could have done that, and we would have ended up, one of the lines would have had true premises and the false conclusion. But it's much quicker and easier to use an indirect truth table method. Let's go on and do one more example. Let's go on to our next example. This proof we have, not A implies B, one of the premises. B implies A is another premise. A implies not B, the third premise, with the conclusion being A and not B. So if we're going to use the indirect truth table method, then we're going to assume the conclusion is false. So we have a conjunction here, and as we know with a conjunction, any time that we want it to be false, it can be false any time any of the A or B is false. So we can have this true and then B true, and that would make B false because of the negation sign, right? And then so true and false makes this false. We can have A true and B false, but that makes that true, so that would make that true, so that one doesn't work. Then we have A false. So anytime A is false, or when B is true, we know that this one will be false now because it doesn't matter what B is. So let's start playing with this. And sometimes it's not always clear what you're going to need, but we just go play with it. So we know that we need this premise to be true. We need this premise to be true. And we need this final first premise to be true, right? We need to have two true premises and a false conclusion. So we know that with B implies A, we can't have A be false here. Because if A were false, well, actually we can have A false if B is false. So let's try, let's see here, let's make A true and make B false. That would make B true here. True and true. Okay, so we can make that true. So if A false, B true. So if A true, B false, that makes it true. So no, that wouldn't work there. So we can't do these. So let's make, if we make B true, that would make it false. And A true implies false, makes false. Oh, so now we have a false premise. Okay, so we can't do it with either B being either false or true. So let's try making A false. Okay, and if we make A false, we found then that that would make the conclusion false. So now we know that A is going to have to be false. Okay, that's the only way it's going to work if we're going to try to make it invalid. Remember, the point here is to try to make it invalid. If you can't make it invalid, then it's valid. So if A is false, then it doesn't matter what B is, and it will still be true. Okay, so far so good. So if A is false, that would mean B would have to be false here, because if B were true, that would make this false, right? Because true implies false is false. So B has to be false in order to make that true. And A has to be false. But that negation makes it true, and B makes it false, so makes it false. So as you can see, we can't make all the premises true and the conclusion false. We end up getting contradictions, right? We just can't do it. And the reason you can't do it is because it's a valid argument. You can't make the premises true and the conclusion false, because that's how valid arguments go. They always preserve truth, and so true premises always lead to true conclusions. An invalid argument, you can derive a false conclusion from true premises, but we can't do that here. So as you see, you just kind of play with it and you try to make it work, and in this case we weren't able to make it work, and the reason for that is because it's invalid. Not invalid, valid. Valid argument.
We can also use truth tables or the indirect method to test statements for consistency. So it's similar to using the indirect method to determine if an argument is valid or not. We can also use this method to determine whether a set of statements is consistent or not. So recall, as I discussed earlier, if I am consistent, then what I say to be true will be consistently so in different circumstances in different places. A politician like Lincoln, who I mentioned in the example before, who tells one crowd he is for tax cuts or for slavery, and another he is against tax cuts or against slavery, is not being consistent. So let's turn to an example.
In this example, we're going to use truth tables and the indirect method to see whether these statements are consistent or not. So as you'll notice, we have single forward slashes between the statements. This is not a proof. This is just a comparison of statements. So if these statements are all consistent, then that means that we can make every one of them true. Okay? So we'll put a true under main operator of each and every one of these statements. Okay, so now we can begin figuring out what we need the truth values of these various letters to be. So if this is going to be true, then A has to be false, right? Because the negation sign will reverse the truth value and flip that from being false to true. So A, we know, has to be false. So we can put false in here, And let's see here. And then we have A is false here. Okay. So that means with this first one, if this is going to end up true, B cannot be false, because then that would make the whole thing false. So we'll have to make B true, and that makes this one true. So we've got that one true. We know B is true now. And so in order for this one to be true, we have to have this not be false, right? Because true implies false would give us a false implication. So that means that C has to be true. Okay. And that would make this true, and then that would make all of this true. So far so good. This one can be made true, this can be made true, and this last one can be made true. But now we know what truth values we need to do this. So let's plug this in. We have C. C is true, so put true here. And B is true. It had to be true, remember? So I put true here. But the negation sign reverses the truth value and makes B false. So now we have a true implies false, but that doesn't make that true, that makes that false. So we cannot make all of these statements true using our truth table analysis or indirect method. So that means that these statements are not consistent.
So what we have done with these truth table argument forms is we've shown certain argument types to be valid and other argument types to be invalid. And over the centuries, a number of common argument forms have emerged in logic. And every time that argument form emerges, we know that the conclusion follows from the premises, and so that truth is preserved. If the premises are true, then the conclusion is true. And so these argument forms are all valid, and we could use truth tables to prove that for each of them if we wanted to. We use the truth table to prove an invalid argument form, which is a fallacy called affirming or denying the antecedent, which we'll look at a little bit later. But we could also use truth tables to prove that they're all valid. The valid forms are valid. So by drawing on these argument forms, one can begin to construct logical proofs, which is what we will do in the next and final section. But first on to the common argument forms. And so for each of these argument forms, such as the disjunctive syllogism, we could put it in the argument line and try to make the two premises, P or Q, and then not P, true, and then the conclusion false. We would find that we could not do that because the disjunctive syllogism is a valid argument form. Okay, so this form, if we have any of these two lines, P or Q and not P, anywhere in an argument, we can automatically conclude Q, right? So as we saw earlier with the disjunctive syllogism, we have an either or. Either you will pass this class or you will fail. If you did not fail or not F, then we can conclude you passed. Okay, so that's one of the argument forms. Another argument form is the pure hypothetical syllogism. P implies Q, Q implies R. We can conclude P implies R. So a hypothetical syllogism can run for an indefinite number of links, but 2 or 3 is what is most common. To state this as an example, we can say that if you pass the final, you will pass the class, and if you pass the class, you will graduate. From here, we can conclude that if you pass the final, you will graduate. This is an example of the hypothetical syllogism. The letters in parentheses after the name are shorthand for how that argument form is identified in a proof, which we'll be doing in the next and final section. Modus ponens, one of the more common argument forms that we have already talked about a few times in this course. Modus ponens is the Latin for the implication statements we have seen throughout. For example, if you study, then you will pass. You studied, therefore you passed, is an example of this argument. Modus tollens is similar to modus ponens, but it is the negation of the consequent. Remember, the consequent is what follows the horseshoe. It's the second term of a conditional statement. But it is the negation of the consequent that allows us to infer validly the negation of the antecedent. If it is true to say that if you study, you will pass, then one can infer from the fact that you did not pass that you did not study. So that is a valid argument form. Now, there are two invalid forms that are very similar to modus ponens and modus tollens. The first is affirming the consequent. P implies Q, Q, and therefore P. Okay. We have seen this before, and we have used an example to clarify this as well. With the modus ponens argument, if you study, you will pass. You studied, you will pass. The invalid affirming the consequent form concludes from the fact that you passed that you must have studied. But that is not necessarily true. It could have been a very easy test, etc. Okay. So, and we could plug this into an indirect truth table analysis, and we would be able to make the premises true and a false conclusion. And so you might try that just for fun in order to see how the truth tables are related to these argument forms. The other one, this is the one that we did do for. We were able to show that this was an invalid argument form. This is the denying the antecedent. This argument is also invalid, but it is commonly made anyway. It is closely related to affirming the consequent and really says much the same thing, but in a different way. So for instance, if you say you did not study, you cannot conclude that you did not pass. And for reasons discussed in the previous slide, the test could have been very easy, etc. Okay, so back onto the valid forms. A constructive dilemma is a valid argument form. And again, we could put this all in one line and do a truth table analysis and show that it's a valid form. Now, this argument looks complicated, but it is really quite straightforward if you plug in statements for the letters. So, for example, we can take cat for P, dog for R, furballs for Q, and fleas for S. The argument reads as follows then, and makes perfect sense. If you get a cat, then you'll have furballs, and if you get a dog, you'll have fleas. You will get either a cat or a dog. Therefore, you will have either furballs or fleas. Makes perfect sense and is valid and true. So if the premises are true, then the conclusion will be true as well. Destructive dilemma is a slightly different way of making a similar point, though with a slightly different variation. So stated in terms of the example from the previous slide, if cat, then furballs, and if dog, then fleas, neither furballs or fleas, so neither cat or dog was gotten. So with these argument forms and with what we now know about using truth tables to analyze arguments, we should be, and you should be, ready to go on and do the exercises. And so these are the exercises for section 7. Make sure you've reviewed the text and this video and feel comfortable, and then go on to do the exercises. Then you can watch the exercises video and try to make sure you iron out any kinks that might be remaining, and then go on and take the quiz. Good luck.